Hello guys, welcome to the class for today. Today we are going to be looking at application of the principle of linear momentum. Okay, so if you have not subscribed to this channel, please subscribe to this channel. Click on the notification button so that when we upload a new video, YouTube will notify you. You can also reach us through the WhatsApp number that is right before you on your screen. Right, so I remain on top of my care, and for this class today we'll be looking at applications of linear momentum. So get your writing materials ready, get your calculators so that we can go straight to the class for today. Applications of linear momentum. So one area where this principle of linear momentum is applied is in the recoil velocity of a gun. You know that when a gun is shot or when a bullet is fired from a gun, the gun will move backward. As the bullet is being fired, the gun will move backward. That moving backward is called recoil. So that velocity with which the gun recoil is what is called recoil velocity of a gun. So when a bullet is fired from a gun, the gun jerks backward or recoils. Now before the gun is fired, the total momentum of the gun and the bullet is zero. The total momentum of the gun and bullet system is zero because before the gun is fired, the gun and the bullet they are at rest. But when the bullet is fired in the forward direction, there is a recoil of the gun in the backward direction. So assuming m1 is the mass of the bullet and v1 is the velocity of the bullet, and m2 is the mass of the gun and v2 is the velocity of the gun, where v2 is the recoil velocity of the gun. Since the momentum of the gun and since the momentum is conserved, we will have that the total momentum of the bullet is equal to the total momentum of the gun. Is that okay? So we have that the total momentum of the bullet is equal to the total momentum of the gun, and the momentum of the bullet is mass of the bullet and its velocity, and then the momentum of the gun is mass of the gun times velocity. So this equation is the equation to solve for the recoil velocity of the gun. The recoil velocity of the gun is v2. Is that okay? The recoil velocity of the gun is v2. So we will solve a problem now to buttress this or to drive home this equation. So this is a sample question. So a submachine gun of mass 20 kg fires a bullet of mass 100 gram due SAT with a velocity of 250 meters per second. What is the recoil velocity of the gun? Okay, so we know that if the bullet is fired to SAT, which means that the gun will move northward. Is that not so? Fine. So the information that I'll be giving to us here is that they gave us the mass of the gun. We can say is M1 to be 20 kg. They gave us the velocity of the gun, U1, to be equals to, no, the velocity of the gun is not given to us. It's not given to us. So that's what we're looking for. Mass of bullet is given to us to be equals to 100 gram. So convert this to kg. That will be 0.1 kg. 0.1 kg. And the velocity of the bullet is given to us to be equal to, the velocity of bullets is given to us to be equals to 250 meters per second. Okay, so from that equation we had that Momentum of bullet is equals to momentum of gun. So for bullets, we have that 0.1 multiplied by the velocity is equals to the mass of the gun times V multiplied by V will give you V. So V, which is the velocity of the gun, recoil velocity of the gun, is 0.1 times 250 divided by 20. So actually calculations on recoil velocity is very simple and cheap to solve. So by the time you solve this out, you have that the recoil velocity of the gun is 1.25 meters per second. I hope this is quite simple. If you can just apply that equation, it's quite simple to solve. Okay, that one is simple to solve. Okay, so that is for, we've discussed the recoil velocity of the gun. Another area where the principle of of conservation of linear momentum is applied is on the jet and rocket propulsion. Jet and rocket propulsion. So we know that when a jet is propelled from the earth surface, it is the force of the gas that is burning that pushes the rocket forward. As the gas, the hot gas, is coming from the tail or from the exhaust of the rocket will be moving forward. So a jet of hot gas is expelled downwards through the nozzle at very high speed from the rocket or aircraft. An equal and opposite momentum is given to the rocket, which moves forward. The same thing that happens in aircraft. So as the jet of hot gas is being expelled from the rocket, the force of the expelled gas pushes the rocket forward. So the equation that applies, the rate of change of momentum of expelled gas is equals to the total force experienced by the rocket. Okay, so we know that rate of change in momentum is equals to force. Rate of change in momentum is equals to the applied force. That is the statement of the Newton's second law of motion. So mass of expelled gas, rate of change of momentum is mass of the expelled gas times its velocity. The mass expelled per seconds times the velocity is equal to force on the rocket. So for rocket propulsion, this is the equation that applies. Mass of expelled gas per second times the velocity equals to the force or thrust. Right? You can either say it is force or thrust. Thrust that is experienced by the rocket. So this is the equation that applies for rocket propulsion. Okay, so we are going to use this equation now to solve some problems too. We'll solve some typical problem. So this is a sample question. A fuel was consumed at a steady rate of 5.0 times 10 to the power minus 2 kg per second in a rocket engine and ejected as a gas with a speed of 4 times 10 to the power 3 meters per second. Determine the thrust on the rockets. Okay, so here you are giving the mass of the expelled gas per seconds to be 5.0 times 10 raised to power minus 2 kg per seconds. Velocity of the expelled gas is 4 times 10 raised to power 3 meters per seconds. So we are asked to find the force or the thrust that the rocket experiences. So from that equation, we have that force or thrust is equals to m times v. So when you substitute your values there, you are going to have 5.0 times 10 raised to power minus 2 multiplied by 4 times 10 raised to power 3. Okay, so when you work this out, if you work that out, you are going to have that the force or the thrust is equals to 200 Newton. So this is the thrust or the force that will be experienced by the rocket. So you can see that the questions on recoil velocity and thrust on a rocket, they are simple. Once you understand the equation to use, they are simple to solve. All right, they are simple to solve. So we still have some other areas where the law of, or principle of conservation of linear momentum as they are also experienced. Like when you are walking is made possible because of the total momentum of a person. Because the total momentum of a person walking is pushing against the ground with his foot is equal to the momentum exerted by the ground on the person. So when you are walking, there is a reaction force from the ground, and it is that reaction force that actually pushes you forward. It is that reaction force that actually pushes you forward. Is that okay? So this is an area in which also the principle of conservation of linear momentum is applied. That is your ability to walk. It is the force that you the force that you exert on the foot, and then the foot now exerts its own force on you that enables you to walk freely or smoothly on the ground. So that is one area where another area of application of the principle of conservation of linear momentum. Now we are going to look at weight of a body on a lift. So far we'll be talking about gravitational motion. We'll be talking about gravitational motion, and for a body that is on a lift, the force of gravity is acting on it, on the body. So, and a lift is designed to carry a particular maximum weight. So the weight of the objects on a lift must be known so that the lift does not become it's not overweight, and then it will not affect the ropes or the slings that are on the lift. So this area of calculating the weight of a body on a lift is very, very important. Is that okay? So weight, we know that weight is given to us as mass times acceleration due to gravity. We know that one before. Weight is mass times acceleration due to gravity. That is a force that is acting downward, right? And we know that weight varies, but mass remains constant. So for a body that is in a lift, different equations apply, and these equations are very, very key, very, very key. So if the body is stationary, that's if the lift is at rest and it is not moving at all, it means that the lift is not accelerating. So acceleration E for the lift is equals to 0. But definitely the force of gravity is still acting on the body, or still acting on the lift. So the weight of the lift at that time will just be equals to mass times acceleration. For a lift that is at rest, the weight on the lift or on the floor of the lift is just mass times acceleration. Now, when the body begins to move upwards, The body now has acceleration A, and then the acceleration due to gravity is also acting on the body. So the body has acceleration A, it also has G that is acting on the body. So the total weight on the lift will be this equation: mass times acceleration G plus mass times the linear acceleration. So for a lift that is moving upwards, the weight on the lift is equals to mg plus the mass times its linear acceleration of the lift. So this one, you can simply bring your like terms together. So you have m is equals to g plus a. So for a lift that is moving upward, this is the equation that applies. Take note, for a lift that is moving upward, it is mg, the mass times acceleration due to gravity, plus the mass times linear acceleration. So that gives you the total force or the total weight of the lift. Then if the lift is moving downwards with acceleration A less than G, that is, if G is greater than A, then the force or the weight on the lift will be equals to mg minus ma. This time the lift is coming down. The lift is coming downward, right? It is coming downward. So this will be the equation that applies. Lift is coming downward with G greater than A. If the lift is descending with A greater than G, we'll have that the weight that will be on this lift will be ma minus mg. So take note of these two equations so that you know when to apply them. If the lift is coming down with A greater than G, it will be ma minus mg. If G is greater than A, it will be mg minus ma. And these are these two equations that are here. Now, if the lift falls freely, a situation whereby the lift falls freely, maybe the rope of the lift cuts. If the rope of the lift cuts, then the acceleration G will be equals to A. If A is equals to G, it means that there's no force, because it will now mean that we have ma plus mg plus ma. So these two are equal. If the two are equal, and then you put your equation that your equation will, since they are equal and the body is descending down, you have mg minus ma. So since g is equals to a, you have mg minus a. So this is 0 now. Since these two are equal, this will be 0. So the whole value of this will be 0. So which means that if the rope of the lift cuts, the body will be weightless, because there will be no force on the body again. So the body will be weightless. So please take note of this statement. These are examples of a JAMB question. So if an object is in a lift and the rope of the lift suddenly cuts, the object will be weightless because there will be no force acting on the body anymore, since G is equals to A. Take note of that statement. Those are typical examination questions. Can ask you, when an object is in a lift and the rope just cuts, what will be the weight of the object? The object will be weightless because the force is 0. And why the force is 0 is because the acceleration due to gravity is equal to the linear acceleration. Okay, So these are the equations for a body that is in a lift, and this is what happens when the body is in a lift. I hope that is understood. So if that is understood, we can solve a problem now. Can solve this problem. A spring balance which is suspended from the roof of a lift carries a mass of 1 kg at its free end. If the lead accelerates upward at 2.5 meters per second square, determine the reading on the spring balance. Okay, so here you are asked to calculate the weight of the body when the lead begins to accelerate upwards. Okay, so you are given the mass of the body to be 1 kg. We are giving the acceleration of the body to be 2.5 meters per second squared, and you are also giving g to be equals to 10 meters per second squared. Okay, so for a body that is accelerating upwards, the force that will be that the body will experience, which should be equals to the weight or the reading on the spring balance, equals to mg plus ma. Okay, so that gives us mg plus a, all brackets. If you substitute into this equation, you have m is 0.1, so g is 10 plus a is what, 2.5. So you can work this out by 0.1 multiplied by 12.5. So when you work that out, you get the weight on the lift. When you work this out, you have the weight on the lift. So can do that calculation by 0.1 times 12.5. So that gives you 1.25 Newton. Okay, so that is the weight or the mass, the weight or the reading of the spring balance. All right, so this is another problem. It's another problem. Say a 100 kg elevator is descending vertically with an acceleration of 1.0 meters per second squared. If the acceleration g is equals to 10 meters per second, the tension in the suspending cable will be what? So here you are given an elevator to have a mass of elevator is also a lift. Is that okay? Elevator is a lift. So the elevator has a mass of 1000 kg and it is descending with acceleration of 1.0 meters per second squared. So and g is given to you to be equals to 10 meters per second squared. So in this particular question, we see that the g is greater than a. So the equation that will apply will be f is equals to mg minus ma. Okay, so you can write this as m bracket g minus a. So you substitute into this equation, you have 1000 10 minus 1, because the a is 1.0. So by the time you work this out, you have 1000 multiplied by 9. So this gives you 9000 Newton, and that is the tension that will be in that string. So that will give you 9000 Newton. Okay, so equations or problems on lift, they are quite simple, and I hope you can relate with the ones we have solved. These two that we just solved, I hope you can relate with them, so that you can use the method that we use to solve any other problem that you will come across, right? So we are going straight now to your test your understanding page. I still have one question to solve before we go to your test your understanding page. Okay, this question says an elevator of mass 4800 kg is supported by a cable which can withstand a maximum tension of 60,000 Newton. The maximum upward acceleration the elevator can have is what? Okay, so here we are given the mass of the elevator to be 480, which is the mass of the lift to be 4800 kg, and then the force that the tension can withstand is equal to, or the force that the string on the lift can withstand, which is equals to the weight, is equals to 60,000 Newton. 60,000 Newton. G is given to you to be equals to 10 meters per second squared. You are asked to find the acceleration A. We don't know A. So since the body is moving upwards, the equation that applies will be equals to F equals to mg plus ma. So this you can also write as mg plus a. So you substitute your values into this equation, you will have that 60,000 is equals to 4,800 brackets 10 plus a, because a that you are looking for. So if you divide these two sides of the equation by 4,800, you will have this will cancel out. That part will cancel out, so you have 12. This will give you 12.5. Is equals to 10 plus a. So you can now solve for a. A will be 12.5 minus 10 minus 10. So when you work this out, you're going to have 2.5 meters per second squared. So this will be your acceleration A. So this is the acceleration of the lift. That's okay. That is the acceleration of the lift. This one, another sample question. A body of mass 2 kg is suspended from the ceiling of a lift with a light inextensible string. If the lift moves upward with acceleration of 2 meters per second squared, calculate the magnitude of the tension on the string. Calculate the magnitude of the tension on the string. So since the lift is moving upwards, we are giving mass. Mass has been given to you to be 2 kg. We are also given acceleration to be 2 meters per second squared, and g is given to you to be 10 meters per second squared. Okay, so since the lift is moving upwards, this is the equation that will apply. It will solve a lot of problems on this, so you should not have any problem with this. Okay, so make you write your equation in this format, and this you impute your informations. 2 g is 10 plus 2. Okay, so you have 2, this is 12. 10 plus 2 is 12. So the weight on the string, or the tension on the string, will be equal to 24 Newton. So I hope all these questions, they are simple, and you should be able to relate with this and then solve any problems that has to do with the weight of a body in a lift, right? Okay, so this is your test page. Please solve all these problems. Post your answers on the Snap, then can paste them on the WhatsApp number that is showing on your screen. We'll attend to all your questions. Is that okay? So we are stopping here today. Thank you for your time. And if you have not subscribed to this channel, please subscribe to this channel. Give us a like, give us a thumbs up. Also reach us through this WhatsApp number that is showing on your screen. Right? We promise to give you best lectures or quality lectures in physics. This is Nobleman Science Tutors Online, and I remain Otobo Michael. We see you in our next class. Thanks.